Hey guys, so today we're going to focus on some of the assignments I gave you for Khan Academy. It was these related rates equations. Um, let's talk about how to come up with solutions for these together. So let's go. Any second now. There we go. Okay, so Anatoly was given this problem. Two cars are driving towards an intersection from perpendicular distances. The first car's velocity is 2 meters per second. The second car's velocity is 9 meters per second. At a certain instant, t sub 0, the first car is a distance of t sub 0 of 8 meters away from the intersection, and the second car is a distance y of t sub 0 of 6 meters from the intersection. At what rate of change of the distance between the cars at what is the rate of change of the distance d of t between the cars at that instant? So they threw a lot of information at you. So the first thing I want to do is I want to draw a little picture for myself. So they said we had two cars coming from perpendicular distances. All right. So imagine that the black lines represent the streets that the cars are driving on. I have one car. Oops. Right there. Let's say that the distance between here and here is that x of t. All right, and we have a second car. It's somewhere over here driving from the perpendicular distance. So let's say this distance is y of t. Right? And I'm trying to find the distance between these two cars. So I'm trying to figure out from here to here, how is this distance changing as the cars get closer and closer to each other? Well, I know they're perpendicular because they told me, so I know I have that right there. So now the goal is to try to figure out an equation that combines x of t and y of t to somehow incorporate d of t. And so here's what I know. I have a right triangle and I have two sides, and d of t represents the hypotenuse. So I can use the Pythagorean theorem. And if I scroll my answer choices, lo and behold, there's the Pythagorean theorem. If I solve that, I could actually go ahead and figure out the question that they're asking. But they just want to know what the setup is, because that's the first part to these problems. You gotta know the setup. All good. All right, next question. All right, the side of a cube is increasing at a rate of 2 kilometers per hour. At a certain instance, t sub 0, the side is 1.5 kilometers. What is the rate of change of the volume at that instant? Okay, so let's look at what they're telling me. They're asking for volume of a cube. So I remember that volume of a cube is equal to the side length cubed. So in this instance, it's v of t will equal whatever my side length is cubed. All right, so it's not the first one, it's not the second one. Oops. So it should be D. All good again. All right, so notice how for these questions, I'm looking at what the variables are and I'm trying to make sense of how do they relate to each other. If I know a formula exists, I'm going to go ahead and use that formula. If not, well, you got to get a little creative and try to think of some sort of equation that might put them together. So for these types of problems, just keep that in mind. There's got to be a connection. If you can figure out the equation that combines everything together, you're all set. And if not, draw something out, see what you can do to help you with this.